Hello, everybody. This is Bert Dixon here presenting on lesson 5.2 from our textbook, which is on place value systems. The most common place value system that we're familiar with is our normal number system, which is the Hindu-Arabic system. That's what we currently use today. And it's called a place value system because each digit represents a place value. Our place value system is based on powers of 10. And so the first digit, or the furthest to the right, is 10 to the 0 power, which is 1, and that's called the units place because it just represents 1 unit. And then the next digit represents 10 to the first power, which is just 10. So that's the tens place. The next digit is 10 to the second power, which is 100. So that's the hundredths place. The next one is 10 to the third power, which is 1,000. 10 times 10 times 10 is 1,000. So that's the thousands place. And then 10 to the fourth power is 10,000. So that's the 10,000ths place. And so in expanded form, this number could be written as 5 times 10,000, or 10 to the fourth power, and then 6 times 10 to the third power, and 4 times 10 to the second power, and 3 times 10 to the first power, and 2 times 10 to the 0 power. And so that represents 50,000. This is 50,000. This is 6 times 1,000, which is 6,000. And this number is 4 times 10 squared. 10 squared is 100, so that's going to be 400. And then 3 times 10 to the first is 30. And then 10 to the 0, remember, is just 1, so that's 2. And so that gives us the number 56,432. Okay, so this is called expanded form using the place value system. So our place value system, as I said, is all base 10, but there are other, throughout history, there have been other place value systems, which we're first going to look at the Babylonian numerical system. In the Babylonian numerical system, they only used 2 symbols. They used a symbol for 1 unit and for 10 units. These symbols here, that's 1 unit, that represents 10 units. And so, for example, if we look at this number, the places, the digits, which we think of in our Hindu-Arabic system, are the places are separated by spaces. So this is one group, and that represents, well, we should probably start at the right. So this is going to be the units. And so that number represents, let's see, we have 3 tens, so that's 30. So this is 30, and this is 2, so that represents 32. The next group is 21, 2 tens and a 1. 21 times, their place values are powers of 60, and so that's 21 times 60. And then the next group is the number 2, and the place value for that group would be 60 squared. So it's units, and then 60s, and then 60 squared. And so 60 squared is 7,200, and 21 times 60 is 1,260. And then our units place is 32, and when we add all those up, we get 8,492. So this Babylonian expression represents 8,492 in the system that we're familiar with, which is the Hindu-Arabic system. They also use a symbol for subtraction, which looks like the units digit, but with this symbol up on top. That means subtraction. So, for example, this is the number 30, and this is the number 3. So we would do, sorry, this is the number 2, and this is the subtraction symbol. So 30 minus 2 is 28. Okay, so we'll work out some examples. By the way, if you haven't printed this note template already, it might be helpful to you rather than having to copy down all these symbols. If you would just print the note template that I made available on our course website, that'll make it a little bit easier for you rather than having to handwrite all of these symbols down. So if you want, go ahead and pause your video and print the note template if you haven't already, and then that'll give you a document that you can just write on as you're working out your examples, as we are working out our examples together. Okay, so for this first example, we typically want to start on the right side because that's the units. This is the number 10 and 1, and so that is going to represent the number 11. And then this is the number 2, and that's in the 60s place. So we have 11 in the units place, 2 times 60 in the 60s place. And then this is the number, this represents the number 12 because it's 10. 10 plus 2 is 12. So this is going to be 12 times 60 squared. So we have the units place, that's 11. We have the 60s place, there are 2 of those, and we have the 60 squared place, there are 12 of those. And so that number is going to be, let me create some space here so we can write them underneath. So 12 times 60 squared using your calculator is 43,200. 2 times 60 is 120, and then 11. And so that number is 43,200 plus 120 plus 11. And so that is 4331. Oh, sorry, 43331 in our Hindu-Arabic system. Okay, so then to convert 4,635 to the Babylonian notation, first we need to look at our place value system. We have our units place, which is equal to 1. Then above that we have our 60s. So our 60s, each one of those is worth 60. 60 squared is 3,600. 60 cubed is a pretty big number. 60 cubed is 216,000. And so those are numbers that we're going to refer to because that's how much each place, that's the value of each place. And so our number is smaller than 216,000, so we're not going to have any 60 cubed, okay? But it is bigger than 3,600, so we know we're going to have one of those. And so we'll have, let's again create some more space here to work this out. Okay, so 4635 divided by 3,600, it goes in 1 full time. If you wanted to write the decimal, 4635 divided by 3,600 is 1.2875. We're going to take the whole number from that, and that's a 1. And so writing a 1 in the Babylonian system would look like this. Okay, and so now we can take the 3,600 off. So we have 4,635 minus 3,600. That is 1,035. Okay, so now we're going to convert that using our next decimal place, which has a value of 60. And so if we do 1,035 divided by 60, using your calculator, 1,035 divided by 60 is 17.25. So again, we're going to take just the whole number part of that. 17 written in this system is, I could write it like this. Sorry, it would be 10 and 7 ones. Which could be written more efficiently using subtraction. That could also be written as 10 minus, sorry, 2 tens. So we would have 20 minus 3. Okay, so that could be written either way. So that is the number 17. And then now if we take those off, we have 10,035 minus 7 60s. Sorry, 17 60s. So 1035 minus 17 60s is 15. And so we have then 15 units. That's already a whole number. And so 15 units is going to be 20 minus 5. Or we could do 10 plus 5. That would probably be the more efficient way. So 20, sorry, there's 10 plus 5. So then we'd have 1, 2, 3, 4, 5. Okay, so then our final answer is 4635. Could be written as this number in Babylonian. It would be, from up here we have 1, and then we would leave a space. And then we'd have the number 17, which we decided could be written most efficiently using subtraction. So there's 20 minus 3. And then we'd leave a space, and then we'd have plus the number 15 units. So there's 10 and 5 ones, 5 units. Okay, so that's what that number 4,635 would look like in Babylonian. Okay, and we can check that. This is 1 times 60 squared plus 17 times 60 plus 15. That should give us our correct answer. So just double checking, 60 squared plus 17 times 60 plus 15, that is 4,635. So that's just a check. Okay. All right. So what I would like you to do now is go ahead and pause your video and try problems C and D. And then go ahead and press play after you've done those 2 problems. Press play to check your solutions. Okay, so for part C, this number represents 21. So we have 21 units. This number represents 13, and those are 60s. And this number represents 3, and those are 60 squared. So we're just going to add those up. And so that number represents 3 times 60 squared plus 13 times 60 plus 21. And that is 11,601. And then the last one, part D, to write this in the Babylonian notation, we're going to have to do a series of divisions and subtractions. Okay, and again, this number is less than 3,600. Sorry, it's more than 3,600, but less than 216,000. I'm looking at these numbers up here. And so we're going to start with a multiple of 60 squared. So 7,573 divided by 3,600 is about 2.104. It's only the whole number that we're concerned with, so that 2 is going to be represented as a 2. Okay, and then we do our subtraction, so we're going to take off 2 of the 3,600. So we have 7,573 minus 2 times 3,600. That is 373. And now we're done with this, the 60 squared. So now we're going to go to 60s. So we do 373 divided by 60. 373 divided by 60 is approximately 6.217. That's again the whole number that we're interested in. So the 6 we can represent as 6 ones. Okay, and then we'll subtract those off of the 373. And that is 373 minus 6 times 60. That is 13, and that is our units. And so 13 we can write as 10 and 3 ones. Okay, so our final answer then is that 7573 can be written as 2 3600s and then 5 60s and 13 units. So that is our final answer for part D. Okay, so next we're going to take a look at the Mayan numeral system. In the Mayan numeral system, the numbers 1 through 4 are just represented by a series of dots. So 1 dot represents 1, 2 dots represents 2, 3 dots represents 3, 4 dots represents 4, and then a bar represents 5. And then we can use a combination of those. A bar and a 1 gives you 6, because that's a bar is 5. So this is 5 and 1 gives us the number 6. And then 5 and 2 gives us 7. 5 and 3 gives us 8. 5 and 4 gives us 9. 2 bars would be 2 5s. So 5 and 5 gives us 10. And that notation continues. So we have the numbers 11 through 19 written using bars for 5s and dots for units. Okay, so we'll refer to that as we go. Also, they use this shell symbol to represent 0, so that if they need to have a 0 placeholder, they have that. Notice that in the previous Babylonian system, there is no 0 symbol. So this became confusing using the Babylonian symbol, because if you needed to represent the number, let's say, if you needed to represent the number 3602, you'd have 1 3600, then you'd have you'd have no 60s, so you would need a 0 placeholder, so you'd have to have space, and then the number 2. And so they didn't have a way to designate their spaces, and so it was hard to tell when things were carved in clay. It was hard to tell if there was 1 space or 2 spaces or maybe even 3 spaces to represent the number. And so that was one thing that was difficult about the Babylonian system, was that they didn't have a number to represent 0 or a symbol to represent 0. So they just had to add spaces in between to represent the numbers. Okay, so in the Mayan numeral system, they did create a symbol, the shell symbol, to represent 0. Okay, and in the Mayan system, they positioned their numbers vertically, where each row represented a different place value. So starting down at the bottom, this would be the units, and then this was it's a base 20 system, but it's kind of interesting that their first one, this represents 20s, and then the next one is 20 times 18. The significance of that was they used they were using numbers that were easy to do calculations for their calendar, and so the 18s gave them multiples that were more typically found in their calendar system. And so this one was 20 times 18, and then this one would be 20 times 18 times 20 to the first power, and so on. And so this represented, three fives, so that's 15. And then this is the number 14, because it's 5, 5, and 4, so that's 14, and that is in the 20s place, so that'd be 14 times 20, which is 280. And then this is 0, 20 times 18, and then this is going to be the number 7, and that is 20 times 18 times 20. And so it keeps going up by increasing powers. If we had one more row up on top of that, it would be 20 times 18 times 20 squared. So this is 20 to the first power and then 20 squared. So their place value system was a little bit strange. So again, if you had different rows, like this would be the units down at the bottom, then you'd have 20s, and then you would have, above that, you'd have 20 times 18, and then the next place is worth 20 times 18 times 20, and then the next one is 20 times 18 times 20 squared, and the next one is 20 times 18 times 20 cubed, and so on. So if we convert those into Hindu-Arabic system, those are ones, those are 20, these are worth 360 for all the things in that place. These are 20 times 18 times 20, which is 7,200. The next one is 20 times 18 times 20 squared. That is 14,000 or 144,000. And then 20 times 18 times 20 cubed. That is 2,888,000. Okay, and so that tells you what each place value would be worth. And so this one, we have 7 times 7,200, which is 50,400. And then this one we have 0 times 20 times 18, which is 0. And then this one is 280, and then 15. So we'd add all those together, and we'd have the value for that number. So that is 50,400 plus 0 plus 280 plus 15. If you add all these numbers up, you get 50,695. Okay, so some examples for you to try. Go ahead and pause your video and try example 2, converting the Mayan symbols for part A, converting the Mayan symbols to the Hindu Arabic number, and then converting the Hindu Arabic number 167,763 to Mayan notation. Actually, I'll do these first 2 with you, and then I'll have you try the next 2. So don't pause your video just yet. And so this first one, starting down at the bottom, this is the units place. And then this would be the 20s place. And then this would be the 360s place, because that's, remember, that's 20 times 18, it's 360. And then this one is 20 times 18 times 20 squared. So that is representing the 7200s. And then above that is 20 times 18 times 20 squared. Which we said was 144,000. Okay, so let's look at the number now. So we have 4 units, so 4 times 1 is 4. And then we have, this is the number 7, so this would be 7 20s, which is 140. We have 0 360s, so that's 0. We have 3 720s, or 7200s, so 3 times 7200 is 21600, 21,600. And then we have, this is the number 6, so that is 6 times 144,000, and that is 576,000. So now we can add up all these numbers. And that is a total of 597,744. Okay, and now for part B, we are going to convert this to the Mayan notation. And so remember our different place values. If we look back up here, these are the numbers that we're interested in. So we have to figure out which one of those will divide into our number. We have the number 167,763. So we're not going to use any of these, but we're going to start with some of those. So we're going to have a certain number of 144 thousandths. So if we do 167,763 divided by 144,000, that is approximately 1.17. All we care about again is the whole number 1, so that's going to be represented using 1 dot. Okay, and then we have, we want to take that off, so 167,763 minus one of these. And that is 23,763. Okay, so the next number that we're looking at is 7,200. So we want to see how many of those there are. So 23763 divided by 7,200 is approximately 23763 divided by 7,200 is 3.300, and that, again, we just want the whole number from that, so that's 3. 1, 2, 3. And then our next number is 360, so we're going to subtract this off 23763. We're going to take off the 3 7200s that we used, and so 23763 minus 3 times 7200, that is 2163. And so now we want to see how many 360s there are, because that's our next place value, is 360. And so 2163 divided by 360 is about 6.008. So we're going to take the whole number from that. That's 6. So that's 5 and a 1 is 6. And then if we take those off, 2163 minus 6 360s. 2163 minus 6 times 360 is 3. Now notice that we didn't use any of the 20s. We didn't use any 20s, so there's going to be a 0 placeholder for the 20s. So we have the shell for that, and then the 3. And so this is what our number would look like in the end. So it would be 1, 3, 6, 0, 3. Check our answer with that. This is going to be the number 3, 0. This is going to be, so that was 0 20s, and then this is 6 360s. And then this is going to be 3 7200s and 1 14,400. And so if we add those up, it should give us the number 167,763. So this is just a check to make sure we did it right. And that is correct. Those all add up to 167,763, which is the number that we started with. So this is our correct answer here. Okay, now go ahead and pause your video and see if you can convert 36,146 to the Mayan notation. Press play when you're ready to see the solution. Okay, so the just to refresh so we don't have to keep looking further ahead, the place values are 144,000. Then the next one down is 7,200. And the next one down is 360. And the next one down is 20. And then the next one down is units. So we want to see how many of those we need. And we don't need any of these because our number is smaller than 144,000, but we are going to need some 7,200. So let's see how many of those we're going to need. So 36,146 divided by 7,200. So what I'm doing is to figure out how many of these we need, we're going to do 36146 divided by 7,200, and it is 5.02 approximately. And so we know we're going to need 5 of those. And so that is a bar. Then once we take those 5 7,200s off, we have 36146 minus 5 7,200s. That is 36146 minus 5 times 7,200 is 146. Okay, so now now that we're done with the 720s or 7,200s, we're going to see how many 360s do we need. Now we don't need any of those because 146 is smaller than that, so we have 0 of those. So we have 0, which is the shell. Okay, and then now now that we're done with the 360s, we go down to the 20s. So how many 20s do we need? 146 divided by 20 is 7.3. So we need 7 of those. So that's going to be the number 7. Okay, and then we'll see what we have left. So 146 minus 7 20s, that is 6. And so we said we need 7 of those, and now we need 6 of these. So 6 would be that. And so our final answer is 5, 0, 7, 6. And again, we can check our answer by saying we have 5 7,200s, and then we have 0 360s, and then we have 7 20s, and we have 6 1s. And if we add those up, 5 times 7,200 plus 0 plus 140 plus 6, that is 36146, and that is the number that we were trying to convert. Okay, so this is our correct answer for that one. And that is it for today's lesson on using place value systems. Have a great day, everybody.